Hi everyone, my name is Victoria MacPhail. I'm a PhD student at York University. Today I'm going to present about community science data and looking at how it adds to our knowledge about bumblebee status, distribution, and natural history across North America. So community science involves volunteers collecting and or analyzing data to answer a research question, usually in conjunction with a university or other academic researcher, but not always. Bumblebee Watch is an example of such a program that is US and Canada-wide. It was launched back in 2014, and participants take photos of bumblebees, send them through a website or through an app, which regional experts like myself then verify. So there's high-quality data being submitted. The Bumblebees in North America database is the main one I'll be comparing to. It dates back to the early 1800s, which is based on museum specimens, as well as most recently field collection. Data has been contributed by over 250 different institutions and researchers, and it's managed by Dr. Lee Richardson. My question is the Bumblebee Watch program contributing new or additional information about bumblebees compared to that collected by the researchers? Does it show an increase in species records, richness, or diversity? Does it show examples of range expansion or range infill? Does it provide any new forage plant information? So to answer these questions, I obviously had to get copies of the data sets. I then cleaned the data to remove anything with potentially incorrect or missing geographic coordinates or issues with species identifications. I removed the community science records from Bumblebees North America, so it's a true comparison, not duplicating. I then plotted it in GIS and split it into the relevant shapefiles, like the per decades and per species. I obtained the relevant US and Canada boundary shapefiles, and over top of this shapefile, I then placed a 100-kilometer square grid and 10-kilometer square grid. And that's about approximately recommending what you use to look at site or population level for bumblebees, as well as a broader survey area. And then spatially join the species records with the relevant boundary files to associate the province and state name, as well as the 10 or 100-kilometer square grid number. I applied a minimum convex polygon on all the species records and calculated the resulting area, which is approximately equal to the range size. Then looked at the number of Bumblebee Watch points outside of that base Bumblebees North America minimum convex polygon, it's approximately equal to the range expansion, like how many points are falling outside of that base range that's provided by the traditionally collected researcher data. So plant information, I collated it from different sources, different columns. I standardized it to remove duplicates, remove synonyms, and converted common names to scientific ones where possible with as much information as I could to make everything as most accurate and detailed as I could. Then exported everything to Excel for further analyses. I did this on various scales from species all the way up through 10-kilometer square grids. Looked at basic summary statistics such as the totals, the averages, the mins and max, species richness, both the standard number of species, but also something called the Menhinick index, which is looking at total number of species divided by the square root of total number of individuals, which helps to account for different sample sizes, which is particularly true with Bumblebee Watch and incidental data collection, where there are very few records per observation period. Also looked at species diversity with the Shannon index, and also looked at unique values per data set per time period. So my first question was, again, looking at the number of species records. So how much is Bumblebee Watch contributing in terms of records? Well, you see from the number of black dots, which is all bumblebees North America, all years, is on the far left compared to the green dots on the far right. There are quite a few more records in bumblebees North America than Bumblebee Watch. We're still getting good numbers of species and number of records. So 44 species from bumblebees, 44 species from Bumblebee Watch is compared to 45 from bumblebees in North America over a similar time period, and 48 over the all-year comparison. This works out to be about 8.5% of all records all years contributed by Bumblebee Watch alone, and 25% of the last decade. So just looking at all records of bumblebees for the last decade, about a full quarter of them came from Bumblebee Watch, which is quite a lot. Looking at the number of records per bee species per data set, in this case, the black line is bumblebees North America all years, the yellow is bumblebees North America in the last decade, and the green is number of Bumblebee Watch records in total. And you'll see there are no lines where the green is greater than the black, but there are 13 species where the green is greater than the yellow. So there are more species where Bumblebee Watch contributed more records than the bumblebees North America in the last decade. So 25% of species had more records from Bumblebee Watch for the last decade. In terms of species richness and diversity, it depends on the scale you're looking at. For total number of species, generally speaking, it's due to just Bumblebee North America, it's bigger in all cases. Unless you standardize it for the sample size, and then actually Bumblebee Watch comes out ahead in several different scales, having a higher species richness. And in terms of species diversity, again, if you look at all years, it's not greater, but in the last decade, in these two different scales, the diversity index is higher with Bumblebee Watch. So more species generally being seen and sort of looking at the diversity index. The second question looks at range expansion. And for this is all species combined for all data. You see top is the black grid, which is Bumblebees in North America all years. The yellow grid is the Bumblebees in North America, it's also orangey. Whereas the blue grid is Bumblebees in North America for the last decade. So again, top grid is the black grid, Bumblebees in North America. You'll see that it's actually greater than in size than the orange grid. And that's also true with the blue grid being greater than the orange grid. So no case for looking at all species is the overall range area greater. But if you look closely, which is hard to see in these maps, the Bumblebee Watch does have points outside of the overall black or blue range, which suggests that range expansion can be considered both in terms of the area of the range as well as the points outside of the traditional range. So again, in terms of the overall range size, so the area of that polygon, Bumblebee Watch range is not bigger than Bumblebees North America. We look at the all-year time period, but in the last decade alone, 15 of the 41 species did have an overall greater range. So we're having more numbers for the last decade. And looking at the number of points outside of the range, so points outside that base polygon, 23 species had points from Bumblebee Watch outside the base range, and 39 species in the last decade had points due to Bumblebee Watch outside the range, the traditional range. So showing range expansion in terms of records outside the known previous locations. This is a couple of figures showing this. This is looking just common eastern bumblebee, Bombus and patiens. You'll see on the left, that's the all-year comparison versus the per decade on the last on the right. And you'll see that for the first case, the all years, Bumblebee Watch is not greater than Bumblebees North America, but the last decade it is. So in the last decade, the orange grid is bigger than the blue grid. But in both cases, there are points of Bumblebee Watch outside the base range. So there are green stars outside of the black or blue polygon. It's the same thing is true with Bombus maculatus. With the all years, the overall area of the grid is smaller, and for Bumblebee Watch, but there are those green points outside of the base range. For the last decade, actually the range is bigger, so the orange grid is bigger than the blue grid, but there are again points outside of the base blue grid basis. This next question looks at examples of range infilling. And looking at the 10-kilometer square grid, which is approximately equal to unique sites, unique populations of bumblebees. In the all-year comparison, about 18% of all grids are unique to Bumblebee Watch. And the last decade comparison, that is up to 28% of all unique grids. So basically all sites or all populations in the last decade are because of Bumblebee Watch. And on a per species basis, 44 of the 51 species had unique grids due to Bumblebee Watch over the whole geographic scale. And this range for about 17% of grids in the of all years is compared to 48% in the last decade. So in the last decade alone, on average, about half of the unique sites or populations of bees is due to Bumblebee Watch. And similar trends exist for the 100-kilometer square data. This is an example for Bombus ternarius and Bombus evidensis. In both cases, we look at all years. There are unique grids, but a third of the unique grids are due to Bumblebee Watch alone. So there are grids where there's just green stars and not black circles. Zooming in, look at the last decade, Bumblebee Watch had about 80% plus unique grids due to that citizen scientists being out there looking as compared to the researchers for Bombus caliginosus and Bombus fesenskii. So again, green stars where there are no unscathed yellow triangles. So our last question looks at forage plant information. So does Bumblebee Watch contribute unique genera? And yes, over all years, where 26% of the genera are from Bumblebee Watch alone. In the last decade, about a third of the genera are from Bumblebee Watch alone. So this is all the plants visited by bumblebees. So if you just look at the knowledge we know of bumblebees from this data set, about a quarter of the data is brand new to science or to researchers due to Bumblebee Watch. And this is similar trend to looking at unique plant species as well. When you look at percent plant genera on a per bee species basis, again, you see this variation between species. This is the total number, again, unique plant genera. But most bee species did have unique data. So 42 of 49 species had unique data due to Bumble Bee Watch for the all years, and 43 of 46 in just last decade. It depends a lot on the species, but the maximum percent for an individual species contributed by Bumble Bee Watch was 76% for all years and 97% in the last decade. So for one species, 97% of all the plant information we have is due to Bumble Bee Watch. Although the average is lower, the average about 35% of all unique plant genera from Bumble Bee Watch is compared to 57% for Bumble Bee Watch in the last decade. So kind of going back and sort of revisiting the question. So does Bumble Bee Watch show an increase in species numbers or records? Yes. It's not higher than the Bumblebees North America database, but it's contributing a lot of numbers, particularly in the last decade, where about a quarter of our data came from Bumble Bee Watch. The total number of species or species richness, when adjusted for sample size, for most scales, it is a higher number of species per area. And the diversity index, while not greater on the all-year comparison, in the last decade, it is higher for most scales. For range expansion, yes, the overall range size is usually smaller than Bumblebees in North America, although it depends on the individual species. But Bumblebee Watch records are usually found outside of the range. So even if the overall area might be smaller in the last decade, we are finding new observations and new points outside of the original sort of base range. In terms of range infilling, so new locations of species, again, there are many 10 kilometer and 100 kilometer square grids that are unique to Bumblebee Watch alone. And yes, again, new plant information. We have frequently been finding, again, quite a few new plant genera only due to Bumblebee Watch. So I think the value of Bumblebee Watch is in this additional data collection over time and especially space. It's able to confirm the historic locations of species and plant information and add to our current data. I think it'll be especially helpful to help document fast-changing additions. For example, species declines and phenology changes due to climate change. And this data is just from 6 years of the program. I'm sort of presenting it as a decade comparison, but it's really just been 6 years. And so as we have increased numbers of observations every year, I suspect the value will be growing increasingly as we go forward in time. So in conclusion, Bumblebee Watch data does not replace the traditional data, but it sure complements it and adds to our overall knowledge. The data can be used to help in bumblebee conservation efforts. And kind of a general plug, the more data we have, especially that's centrally stored and publicly accessible, the better. So if you have bumblebee records yourself, please submit them to the Bumblebees North America database. If you have photos of bumblebees, please submit them to Bumblebee Watch. I want to thank everyone who participated with Bumblebee Watch or contributed to the Bumblebees North America database. I want to thank my funders at NSERC, the W. Garfield Weston Foundation, and the Rare Turtle Research Preserve. And if there are any questions, I'd be happy to answer them. Thank you very much.
Thank you for the talk. And I know Victoria is in the chat. So hello, Victoria. So if anyone has
stays on, I'm here too.
If anyone has any questions, of course, feel free to pop them in the chat and we will pass them along. I think we have about 2-3 more minutes. So Jen says the question, is iNaturalist data integrated into Bumblebee Watch?
No, iNaturalist and Bumblebee Watch are two separate individual organizations. Both data do get fed into the Bumblebees North America database. For this comparison, I did not include iNaturalist. I did remove it as well as Bumblebee Watch from the Bumblebees North America comparison, just to be have a clear community science versus researcher data. So iNaturalist data is definitely valuable and very similar to Bumblebee Watch, and actually has more records. But this comparison was strictly just on Bumblebee Watch.
Perfect. And James is asking, is there currently a centralized place where you can find all Bumblebee records across all platforms?
You can request the data from Leif Richardson, who's the manager of the Bumblebees North America database. It's not a live update, but you can request it. And he does include records from Bumblebee Watch and iNaturalist and the traditional museum specimens. It's just based on what people contribute to him. So yeah, so you can request data from him. And for Bumblebee Watch, you can go on yourself live and check to see what's going on that site too.